Hi guys, I'm Jennifer, and I'm glad to see you again. Today we're going to talk about time dilation, one of the most fascinating theories of relativity proposed by Albert Einstein. One evening in the spring of 1905, Albert Einstein, then a patent clerk in Bern, decided to board a tramcar on his way home. Einstein, who often wrapped up his work quickly to contemplate the truths of the universe in his free time, had a revolutionary thought experiment on that tramcar. While moving away from the Zittglogg clock tower, Einstein imagined the consequences if the tramcar were moving at the speed of light. He realized that at that speed, the clock's hands would appear to freeze, while back at the clock tower, time would progress normally. This realization that time slowed down as speed increased was mind-blowing for Einstein. Einstein's work was influenced by the laws of motion by Isaac Newton and the laws of electromagnetism by James Clerk Maxwell. Newton's laws emphasized that velocities are always relative, never absolute. On the other hand, Maxwell's discovery that the speed of light is constant regardless of the observer posed a challenge to Newton's ideas. This conflict led Einstein to a brilliant thought experiment involving lightning strikes seen from a train platform and a passing train. The discrepancy in the measurements of the speed of light in these scenarios forced Einstein to reconsider the nature of time and space. Einstein's solution to this dilemma involved a subtle adjustment to Newton's laws, ultimately leading to the concept of time dilation. Let's delve deeper into this fascinating theory. Einstein concluded that the faster an object moves through space, the slower it moves through time. This seemingly paradoxical concept challenged the traditional notions of time and space. The conflict between Newton's laws of motion and Maxwell's laws of electromagnetism pushed Einstein to rethink the fundamental nature of the universe. One of Einstein's thought experiments involved a man on a train platform observing lightning strikes on either side of him. When viewed from a passing train moving at the speed of light, the simultaneity of these strikes was questioned. The discrepancy in the measurements of the speed of light in different frames of reference highlighted the need for a new understanding of time and space. Einstein's groundbreaking idea of time dilation reconciled the conflicting principles of Newton and Maxwell. By redefining the relationship between time and motion, Einstein paved the way for a new era of physics. Time dilation not only revolutionized our understanding of the universe, but also laid the foundation for modern theories of relativity. Through his innovative thinking and thought experiments, Einstein reshaped our perception of time and space, leaving a lasting impact on the field of physics. Time dilation stands as a testament to Einstein's genius. Einstein called this absurdity time dilation, and his newfound theory, special relativity. Newton believed the time moved unflinchingly in a single direction forward. Einstein, however, had just realized the time stretches and contracts varying with velocity. Special relativity. Due to its malleability, time, like space, deserved its own dimension. In fact, Einstein claimed that the two were one and the same, together forming a four-dimensional fabric or continuum called space-time, upon which the mundane events of the universe would unfold. Einstein suggested that massive objects like the Sun didn't pull bodies like Earth with a mysterious, inexplicable tug, but rather curved the fabric of space-time around them, forcing Earth to fall down into this steep valley. A highly simplified analogy is the dip in a trampoline made by a falling bowling ball. If a marble were placed on that trampoline, the marble would immediately roll towards the bowling ball in the center. This is also true for Earth's gravity. We are pinned to the ground because space, so distorted by the Earth's mass, pushes us down from above. However, the slump in the fabric around Earth is not uniform, and Earth's gravity grows more intense as we move towards its center, where the curvature is at a maximum. Therefore, like the marble on the trampoline, an object that falls towards the Earth accelerates as it races towards the center of the planet. It falls faster when just above the surface than it does, say, when it is slightly above the atmosphere. But hey, according to special relativity, the faster you move through space, the slower you move through time. This means that time runs slower on Earth's surface than it does above the atmosphere. Now, because different planets have different masses and thus different gravitational strengths, they also accelerate objects at different rates. As we have learned, this means a variable passage of time. This is what happens in the movie Interstellar, when the protagonists land on a planet in the proximity of a black hole. The gravity on the planet is so severe that 1 hour on the surface is equivalent to 7 years on Earth. To understand how motion affects time, let's consider the simplest timekeeping mechanism. A second passes each time the photon is reflected. Let's imagine two people, one in a spaceship slightly above Earth's atmosphere, and the second on top of a small hill just above the Earth's surface. Both are watching a man fall from space towards the ground. Let's say that the falling man is carrying the photon clock explained a moment ago. What do each of the two men observe as the man falls past them? What they observe is eerily similar to what a stationary person would observe when watching a ball bounce in a moving train. As the man falls from space, the light in his clock would appear to move in triangles to the two observers. Time dilation affects every clock, whether it relies on basic electromagnetism or a complex combination of electromagnetism and Newton's laws of motion. In fact, even biological processes are slowed down. Yes, that's right, your head is slightly older than your feet. If you enjoyed this video, please consider subscribing. Thank you for watching and see you next time.